We are going to take a look at inequalities, but first I wanted to go back over solving equations in 3 general steps. Step 1, locate the variable. 2, work from the outside inward. And 3, do the opposite to move a term. We're going to use these same 3 steps when we are trying to solve inequalities. Let's first take a look at inequality symbols and their meanings. First, we have the equal sign. First, I wanted to look at the equal sign because of that's where the inequality signs actually came from. Now, if you look at the equal sign, the distance of the lines on both edges are equal. So if you look at that side and that side, they're the same distance apart. So what happened as time went on is that we felt the need to say, well, two things are not equal, right? One thing is bigger than the other. And what happened was we tilted that sign from having the same distance on both sides to one side being larger than the other side. So what this meant was that what is on the left is greater than what's on the right. And when you tilt that sign the other way, we're saying that what is on the left is less than what is on the right. All right, so that's where these signs came from. So they look like arrows, but it's really saying it's showing you which side is bigger than the other side. Now we also found the need to say that it can be greater than or it could be equal to. So that line under the greater than sign makes it or equal. And the line under the less than sign makes it less than or equal to. So let's take a look at this. It says 6 is greater than 5. Is this true? Yes, this is clearly true. 6 is a bigger number than 5. Now, if you look at the number line, 6 is to the right of 5. If the number on the number line is to the right, it is bigger. Okay? And while this may seem like something that's common sense, when we get into the negatives, we have to keep that same train of thought. What are the positions on the number line? So let's take a look at negative 5 is greater than negative 2. Well, if you look at the number line, the negative 5 is to the left of the negative 2, meaning it's less than. All right? The way I like to think about it is like money. Do you think you have more money when you owe $2 or when you owe $5? If you owe $5, then you have less money because you owe more money. It's in the negative, right? So negative 5 is not greater than negative 2. Negative 5 is less than negative 2. All right? The negative 2 is to the right, so negative 2 is the greater than number. Okay? Now let's take a look at solving inequalities. We're going to use the same methods as solving an equation. We're going to locate the variable, work from the outside inward, and do the opposite to move a term, and keep on repeating that until the problem is over. We can do this because we're going to treat the less than or the greater than sign like an equal sign, right? And we do not change it unless you're multiplying by a negative number or dividing by a negative number. So unless you're doing one of those two things, you're not going to change the direction of the sign. So solve the inequality and graph the solution on the line provided. So we have 6x minus 7 is greater than negative 1. So we're going to locate the variable. The variable is right here. So we have 6x minus 7 is greater than negative 1. So we've located the variable, if we're going to work from the outside and go in, then the first thing I need to get rid of is this minus 7. Now how do we get rid of the minus 7? Well, we have to do the opposite. The opposite of minus 7 is plus 7. So we're going to add 7 to both sides. So that gives me 6x is greater than 6. If we go through the 3 steps again, locating the variable, here it is. Work from the outside and go in. The only thing on the outside now is the 6. So we're going to do the opposite to get rid of it. This 6 is multiplying with the x, and so the opposite of multiply is divide. So we're going to divide both sides by 6. So we get x is greater than 1. Now if we're going to put this on a number line, the first thing we need to do is locate 1 on the number line. From there we're either going to go left or right. Now coincidentally, the direction of your arrow is going to be the same as the direction of the symbol. Mr. Andrade, what do you mean by that? The symbol is pointing to the right. Therefore, your arrow is going to point to the right. Now, because this is not equal to 1, you're going to have a open circle, as you can see right here. That open circle means that that point is not included. Now, if this was greater than or equal to 1, then that open circle would be filled in to say this point is included. So solve the inequality and graph the solution. We're going to do the same thing. We're going to locate the variable, which is right here. We're going to work from the outside and go in. The number furthest away from the x on the left side of the equation is the plus 10. Opposite of plus 10 is minus 10. So we have 2x is less than negative 10. We need to get rid of the 2. There's the x. We need to get rid of the 2. So the opposite of multiply is divide. We divide both sides by 2. And we get x is less than negative 5. The sign is pointing to the left. And it's not equal to, so we're going to use an open circle. So you plot your open circle at negative 5, and your arrow goes to the left. Alright. Again, you can pause, attempt these questions, and just check to see if you're right. Alright, which of the following values are solutions to the inequality? Now what you're going to do here is you're going to plug each value in and see if it's greater than negative 5. That's pretty much all you're doing. So we're going to check each of these. So to check negative 6, what we do is we put negative 6 in for x, right? We substitute into x. So you basically replace x with empty parentheses and put whatever you're saying it's equal to in the parentheses. So when we do this, we get 9 minus negative 6, which is the same thing as 9 plus 36, which gives us 45. Is 45 greater than negative 5? Yes. So room number 1 is one of the answers. Check option 2. If we put a 3 in there for negative 6, we get negative 9. Is negative 5 less than negative 9? No. Negative 5 is to the right of negative 9, which makes it greater if you look at the number line. So that doesn't work. X equals negative 1. When you plug in negative 1, you get 9 plus 6, which is 15. And negative 5 is less than 15. So the answer for this one is 1 and 3. Here's another example. You can press pause and try it yourself. The steps and the answers are there. Now let's look at solving the inequality for v. Write your answer in its simplest form. So we locate the variable and we notice that v is on both sides of the equation. Now we can't solve this if your unknown is on both sides. So what we're going to do is we're going to bring the 10v over by subtracting it, and then that's how we get negative v plus 7 is less than or equal to negative 4, because we want all our unknowns to be on this left side. Now that all of our unknowns are on the left side, we're solving for v. We only have one of these now, so we're going to get rid of the plus 7 by subtracting it, and we end up with negative v is less than or equal to negative 11. Now here comes the rule where we switch the sign if we multiply or divide by a negative number. We have to divide by negative 1 to get v by itself, because that negative is not v, it's negative v. So to get rid of the negative, we're going to divide both sides by negative 1. That gives us positive v. But what you'll notice is that when you do that, the sign just went from less than or equal to greater than or equal to. Alright, that's the only time we change the sign. State all integer values of x in the interval -5 to 0 that satisfy the following inequality. 4x plus 2 is less than or equal to negative 11. Now in order to do this, we're going to solve for x and see what values are possible for x. Now we go through the steps just like we did before. We're going to subtract 2, divide by 4, and we get x is less than negative 3.25. So we're going to put that on the number line. Negative 3.25 is about here, and you're going to the left of that. Now integers basically mean like whole numbers. Alright? Numbers with no decimal on there. If you move to the left of that, because the range of numbers we can use is from -5 to 0. If you go to the left of that, you'll see that the only whole numbers in that interval are -4 and -5. We can include the -5 because of the bracket. If it was parentheses, we wouldn't include it. So identify integer solutions between -5 and 0 inclusive. These are all the numbers I can use between -5 and 0, and the only two whole numbers are -5 and -4. And that's it. Hopefully this helps, and let me know if you have any questions at all.